First of all, I'm super happy to be here. It's pretty satisfying knowing that 3 years ago I was volunteering at this conference and now I'm talking. So my name is Fábio Carballo and I work at N26. We at N26, can you hear me like this? Yes? Good. So we at N26 are trying to become the world's bank and basically the first bank you will love. What is really important for us is to make banking beautiful and to provide an easy way for you to manage your finances. For example, using the Spaces feature that you can see there, which is basically our sub-account feature and coincidentally the feature I work in, so I want to showcase it. But let's get started properly. So during the last year and a half, N26 went into hypergrowth mode, which means that according to the theory, we had at least an annual growth of 40%. As a good example of the crazy ride this last year has been, when I joined the company in February 2018, the general Slack channel had 400 persons. And now it has 1,300 persons. But for now, let's focus on the Android team reality. So this long journey started in October 2014. That was when N26 was born. At that time, as a new startup, of course, nobody would suspect how big we would become. And we had a pretty much regular Android development oscillating between 3 or 4 developers until 2016 when we got our banking license. This was for sure a turning point for us, and we basically realized we had to step it up and prepare ourselves to scale because things could actually go really well for us. So during the 2017, we were setting up the stage to it. By the beginning of 2018, we basically said we're going to hire. And we started hiring until the end of the year, and we were 14 developers. But this growth continued, and right now, we are sitting on 27 developers. What is interesting here is that if you take a look just to the last year and a half, you can see that we got a growth of 500%. As you can imagine, growing that fast in this small amount of time is not an easy task. Also, what is pretty interesting is that out of this huge team, only 3 or 4 developers had actually experience with Android teams larger than 5 members. So we're basically all newbies, and this is a challenge for everyone that we have to figure out as we go along the way. So what I want to talk to you today about is what comes with scaling the team. I could easily talk for a couple of hours on everything that this scale comes with. We could talk about recruiting, onboarding, automation, releases, team culture. I'm not going to talk about it, sorry. What I'm going to talk about is about technical readiness. So what do I mean by this? Every time your team grows, you feel changes. And with it, some failures on your technical structure can start to arise. And some bottlenecks will become more evident. Also, you will start to see some issues arising when you're trying to deliver your features with more quality. However, as long as you have some of this technical readiness and be mindful of the challenges that you have regarding code, modularization, testing, and design, you will have a more or less steady road to the growth of your team. So, let's start off with our approach to code and what are our ground rules to it. So we have this base principle when it comes to code, and this is the broken windows theory. So according to this theory, the probability of a building to get a broken window when it already has another broken window is way higher when compared to a building that is in perfect conditions. This way, if you don't fix your broken windows, you will see it degrading like super quick. On the other hand, if you first fix your first broken window really quick, your building will keep itself in good conditions for the times to come. If we apply this theory to code, we can say that a good looking code base has more chances to keep a high quality than one that looks like chaos. So when dealing with such a large code base, it's imperial to provide no shortcuts, no hacks in order to get the features shipped. Because if that happens, you'll see a disease growing slowly and when you realize it's too late, because when you have a code base that has around 500,000 lines of code, it will be for sure slow to invert the damage done. And still talking about code, let's talk about architecture. This will for sure always be the highly debated topic at any team, but in my view, you just have to keep in mind that there is no perfect architecture and there is always trade-offs to be made. So just think that a good architecture just provides you an easy way in your team to develop these features rather quickly and in like a scalable and sustainable way. So in my view, there are 4 crucial points that you should take when defining your architecture. The first one is reducing the number of discussions. A good architecture should move discussions out of the way so that we can develop our features with the less problems possible in a systematic way. Also, it should contribute for onboarding. If your architecture defines good guidelines and limited openness, the new people can just come in, ship features, and be productive. And it feels really special when you have a new hiring come in, and in the second day, they're closing a PR. Also, you should embrace evolution. Your architecture will not be perfect. The technology is always evolving, so you should take into account and kind of do this versioning of your architecture because things will change. Also, favor testability. Testing is like one of the pillars of any good app, so take this into account when thinking about our architecture. And also, the architecture should protect you from making mistakes. A good architecture and the good evolution of an architecture will constrain your number of paths so that you can't mistake less than normal. So with this being said, let's take a look to some core ideas of our architecture. So basically, if we did an X-ray to our app, you would see that some of the core ideas of our architecture are reactive paradigm, layered architecture, and dependency injection. Of course, we have more, but I want to focus on these ones because this is the ones I find like really key. So starting off with the reactive paradigm, let's take this example where the user is on our Spaces dashboard screen. So again, our sub-account screen, and taps to check the details of their main account space. At the time, they receive an incoming transaction of 10 euros. So what will happen here is that a call to the Spaces microservice will be triggered, and this service will reply with the current information on the user spaces. Let's take space 1, space 2, and space 3. They are then put on the store, and that due to its reactive nature, it will disseminate the information to the observers, and this will spread along the view model and then eventually pass this information to the screen, which will basically update the balance. What is interesting here is that in parallel, the same fresh spaces information is being passed onto the Spaces dashboard view model. This way, when we press back and end up on the Spaces dashboard, we will see that the balance is already updated. We can then see that with the reactive approach, we can reduce the need for synchronization in your code base as the data is pushed naturally to all interested and they can react appropriately. In the end, this will create a simpler code base that has less problems of deal with the fast influx of incoming requirements. So with the reactive explained, let's see about layered architecture and how it favors a scalable team. This, of course, is one of the most well-known principles, and that says a lot of its value. In general, by splitting our features into well-defined layers, such as domain, presentation, and data, you are able to first clearly break down your features into different responsibilities, and secondly, promote loosely coupled components inside your feature. With this, what you get is, in one side, you get the ability to safely refactor one layer without touching the other, and the ability to have multiple team members to work in different layers at the same time. And this naturally helps a lot on big teams. Also, it's nice to define your dependencies between the layers following the dependency inversion principle that states that high-level modules should not depend on low-level modules. The reasoning here is that the high-level modules of your app, such as domain, will be the parts that are more stable. It's the business logic. And they should not depend on parts that constantly change, such as data and presentation. So finally, dependency injection. Logically, after you define your layers correctly and in a clean manner, you need a way to connect them all together. By using dependency injection, you will get the needed dependencies created and injected in these components, creating this glue between different components of your app. Also, if you're using dependency injection correctly, you are probably using a nice architecture that promotes testability of components because they are loosely coupled. I also wanted to add, and this is just an opinion, that it's in big projects it is handy to do it with a library that does compile time checks. Because in an app, and I took these metrics, believe me, that has around 400 activities or fragments, it's not reliable that we do it on runtime, as we would have to verify all flows, or at least make sure that we didn't break anything. So after this overview of values that promote scale, let's see how we approach the definition of our tech stack. And my opinion is that you have to be ruthless about it, because every time you think about adding a new library or integrating with a new third-party SDK, you should do the following questions. Like, which problem is it solving, and what is the impact of it? Do we really want another annotation processor in our project? How will build times be affected? Do we really want to push this technology that is not that stable and maybe considered legacy really soon? And is it actively maintained? Do we really want to add this library that will be the base of our architecture and that it doesn't have an active community around it? So if you jump head first into these hype trains or don't do a solid evaluation of this new tech tool, you might end up on a really tricky situation. One good example is that due to a partner which we integrated with their SDK, they provided transitive dependencies of an older version of HTTP. And we were stuck in a version of retrofit that dates from 2016. We were stuck for 2.5 years with an older version that made us write worse code and create more legacy. And in tech, just to give you perspective, 2 years is a lot. If you think 2.5 years ago, Kotlin was not an official Android language, RxJava 1 was recently out, and Butterknife was still a thing. And we, being a bank, have to be ready to jump in the most secure tech stack at any time. In which position we would be if there was any crazy exploit of an older version of retrofit meanwhile. A hard one for sure. So even worse than this, and as a bit of a joke, when we fixed the first partner, it was just to realize that the second partner provided the same exact problem. So pick your partnerships really well, please. And taking this conversation of 3 third parties, I just want to have a side note that wrapping behind an interface is actually good. I'm not going to say it's good 100% of the times, but I have a really good example. So being a bank, we are highly regulated and we need to be able to respond fast to requirements that come without warning. So last year we had some problems during our sign-up flow with the quality of our images, and we needed to improve it right away. So these, of course, would come with the camera library change. And the first problem was that the camera interactions were not abstracted at all, and everything was coupled. So for that reason, naturally, we had a hard time. First, we had to extract the camera interface, and then put the camera lib 1 behind it, and only then we could bring the camera lib 2, which should fix a lot of our problems with crashes and blurry images. So this was like a big process. Like, this took 5 seconds for me to say, but in reality it took a lot of time. And we can only conclude that due to this initial huge coupling between the camera lib and our code, we were just slow and not being able to respond with the velocity that such a highly regulated environment requires. But picking up with this story, I'll also do another side note about how to keep your code flexible after the release, which enables teams to control the full feature launch and not rely on constant releases processes. So, resuming, we did all of this, and basically we packaged both camera libs into our APK, with the camera lib 2 being the one chosen by default. We started the rollout, sit, and observe the behavior. No crashes, seems good. But then our partner comes in saying, come on, the pictures, where is the metadata? And we basically, were not being able to sign up in some phones, fragmentation, and we basically had to go run to Firebase and say, please remove camera lib 2 and bring back camera lib 1. So this is a good example of how you don't need to rely on releases to control the a feature launch. And if you imagine we have, I don't know, 12 teams, if we are all shipping new features or improvements in one release and 6 of them go bad, we can't rely on doing new releases for every feature that went bad. We basically have to have this control mechanism that provides experimentation and the safety net to fall back on if everything goes wrong. So moving now to branching and workflow. So before our team expansion, there was no need for a lot of rules. Like we could have Lucia doing relatively small branches on her feature, while I would do a big, long feature branch that eventually, after some weeks, it would end. I'm looking because the animations are not working on my computer. And eventually, of course, I would merge back. The thing is, when you have Omkar, Ilke, Sergio, Mustafa, and basically 20 more persons, things could be really chaotic if there are no rules of structure. You have to take into account that at this scale, and for me this was one of the defining moments when I saw, oh, we actually grew a lot. Like, I pulled develop and I was 220 commits behind in one day. And this is a lot of daily code changes, which could eventually create a lot of merge conflicts, right? So, no problem, this is easily solved. So branch out and branch in small chunks. Your PRs should not have more than a positive or negative 1,000-line changes. And if they do, your team member will rightfully say, break down these PRs. And if you're developing a big feature branch, you don't do a feature branch that will eventually create merge conflicts. Basically, you hide it behind a feature flag or something similar. And now, just about commit messages. Another improvement regarding our workflow was about that we had this problem where we had unstructured messages that provided no value in case you were looking at some issue with a line of code, trying to understand what were the decisions that led to that code. So what we did was we basically used what Jira already gave us, which was generated ticket numbers, to create a more auditable code. We created this Git hook that would follow your dev workflow, look up into your branch name, and should have the ticket number and prepend it to the commit message when you add new code. This then adds valuable info to your commit that you can use to search either in the pull request description or in the Jira ticket of its story. And, okay, this is the fun one. Modularization. So, as most of the apps in 2014, we started out with the single module app. And that story kept itself along 3.5 years until we reached 2018. At this point, we started thinking that we had some problems. And with the eventual growth that we would have, this would not be easy for us. So one of them was that when you have a single module app and you start out with a single team, you can see a number of concepts starting to appear in the code in a natural way. For example, we could see the concept of the user and the ability to log in. And as time goes by, more concepts will appear and the app will slowly become more complex. The thing is, when you have a big team, and this team is working on a code base that basically has no boundaries, the odds are high that you will not be only creating connections that are not so explicit, and the joint work of all this amazing developer team will end up creating this kind of hidden coupling, which of course is problematic if you want to scale and promote separation of responsibilities and be able to do fast changes in your code base. So with this scenario, what we had to basically step back and ask ourselves, how could we improve the situation? And the answer was clear, and it was called modularization. Our initial approach to modularization was breaking down a feature into 3 modules. So we would break the transaction features into transaction presentation, domain, and data. And then naturally, the app would depend on the transactions presentation modules, and so that would happen for any other number of modules. Our initial assumption was that we would have scenarios where one feature domain would need the domain of any other feature. For example, if we wanted to display transactions on spaces, eventually we could have spaces domain depending on transactions domain. And so we started our modularization journey, eventually reaching 100 modules by the beginning of 2019. By the time, we were happy with our approach, but we basically realized one thing. Our initial assumption was incorrect, and it didn't fit the technical vision that we have, where we have standalone features that are basically installable. So we actually started merging the layered modules into one. This way, we see our modules as totally independent components that only communicate with one service from where they should get the data from. If by any case, for instance, our spaces feature would need anything from the transactions microservice, what would happen is that we would create this backend for front-end service that would be dedicated for that, moving that hard logic outside of the app, making it simpler. And so we started working slowly on merging some of our modules, but as growth doesn't stop, you don't see a big drop. But I bet you're wondering about build times. And I can say they're interesting. So regarding build times, we started around 1.5 minutes in 2014, and until 2018, the time was slowly growing in a natural way. However, in 2018, we basically started growing the team, and with that comes a lot of code, and we basically saw this huge increase until 7 minutes. We stabilized a bit, which was good, tooling and modularization. But the big thing was in April 2019, and we had a huge drop on the build times. So what actually happened was that we got some upgrades. This to say that while we love big engineering problems and finding good solutions for it, sometimes you can just use heavy machinery to help us move faster and at a cheaper cost. Well, like with these new machines, we can actually move almost 2 times faster to find better solutions to decrease the build time. But, well, this story, of course, doesn't end here. We are not satisfied, so we started building feature launcher apps. So this basically goes like this. If you are a developer at the credit team and had a new feature to build, you would usually have to build the N26 app, right? And with that, a lot of modules. And that could easily take between 1 and 5 minutes build time. And I'm being extremely optimistic when I say 1. So his solution is to actually create this launcher app that just provides a really simple login screen. And what this causes is like that we have 15-second build time. I'm not kidding. This is super stable. And I don't even know how much percentage of growth is this, but it's too much. And it's really good, and you feel super productive. So I just also want to touch in this modularization part about our biggest challenge when doing it, because we're still modularizing. We are a bit far from ending this process. And the problem is that when we build the app initially, we have what most of the people would have, like a dependency injection graph that would be something along these lines, like app component, then a user session component, depending on it, and eventually down there we could have credit or spaces components, so feature components. The problem is that when you start modularizing, and if we focus like on this credit component, you will see that credit component is wondering, where is app and user component? How do I get this info? And basically what you have to do is extract these high-level things from the app and invert the situation. So you create a lower level base module where you put all of these things. The problem is that when you have such a big code base, this is a slow process, and then is where you start feeling these things of the hidden coupling showing up. This is a real-life scenario. I was trying to modularize my feature, and I started doing it, I found a problem. And I created a new ticket. Okay, I need to fix this one. So I started fixing that other one, I found another problem. And I created a third ticket. And then I started again, and I found another one. And then I gave up. Then we had to take better actions to it, because it was not good. But, well, let's end on a positive note. So modularize for scale. Why should you do it? First, you're able to create independent teams by splitting features into different modules. Different teams can take ownership of specific modules and become more autonomous on decision making and the future of this feature. Also, it allows you to refactor with more safety. So you start creating these boundaries between your code, and you can refactor it easily without the fear of breaking something else on some weird place. In contrast with monolith apps, where you have to do full refactors, here you can go module by module and even layer by layer inside that module. So it's way more controlled. And also it stimulates creativity and innovation. Modules is the way to go. Like if you try to think of a monolithic app and you try to introduce a new tech, it can go really wrong. If in the end, after a couple of months, you understand, oh, this is actually not that good. But if you have modules, you can have a legacy module using async tasks, then another module using RxJava 2, and another module trying out some coroutines. And even if the decision in the end is not that good, you can quickly revert it because it's super self-contained. And now, testing. So the story about testing in N26 is a more recent side of things. So basically our number of tests was really small, and in the beginning of 2017 we had 200 unit tests and no CI. So value is 0. So, but that changed, and we started betting on the most easy way of testing, which is unit tests. So they're easy, they provide you a safe way to refactor and make sure that you didn't break anything, and they let you sleep well at night. And so we started this journey of unit testing, and we increased, eventually reaching at the point we are now, which is basically 8,000 unit tests. Of course, this is good, and we're pretty satisfied with that, but in the end, there are still bugs happening, and the time that we spent searching for them during the manual regressions was too damn high. So it was a big process that consumed a lot of time and created a lot of frustration for everyone. I basically did once and swore that I would never do it again. So it's not that we didn't have automated testing. We actually had, and we were using Appium. That was an initiative started by the QA team, a really good one at the beginning, but it had some problems. Basically, it created two parallel streams of work. So one, for the QA team, developing Appium tests, doing things really well, and then there's us, the Android team, breaking their tests just by changing one ID on an XML. There was a lot of back and forth, a lot of confusion between the teams, and without a lot of success. So what did we think of? Okay, let's try to put Kotlin on Appium so that the Android developers can be more engaged. But in the end, it didn't work out. Sorry for spoiling you. But basically, there was too much context switching. You had to have IntelliJ and have Android Studio and then switch projects and then merge your code and go in a hurry to merge the code on the QA team projects to make sure that things matched. So it doesn't work. Also, when you scale, you start understanding that usually the major blockers for your team are other teams. So it's way better as a team to have full control of everything that it takes to develop and ship a feature. And we wanted to basically own quality as well. So for that reason, we decided to own more of the quality of our app and basically started doing functional UI tests using Espresso. And so in the beginning of the year, we started this small curve. Where is the curve? It's there. So it's 400 UI tests. It's a humble number, but it provides a huge amount of value. Basically, you can go, we went from an automated regression level of 10% to 50% in just a few months. I really hope that in the end of the year, we're like, going to high places. And the experience has been really good. So still talking about UI testing, so we bring UI testing to our team, but then we are faced with this problem. We are a big team. And if we want to run the full UI tests, we have a problem because it's going to take a long time. Usually they're slow, they're like hard to fix, and sometimes they're flaky. It is what it is. So what we did was that we created this script that takes into account two things. So first one, the git diff of your pull request. So here I would do something that would change the space name. And then it takes into account also the structure, the module structure of your project. And basically compiles all this information, does its things, and will say, okay, what I think you should run is you should only run the UI tests on spaces. This is what I feel is more valuable. So what this allowed us was to go from a UI testing pipeline that had 30 plus minutes to actually 3 minutes in the worst case scenario. So this is a dramatic improvement and made us able to produce UI tests for new code with confidence and still get super fast pull request pipelines that don't create bottlenecks on a team that produces dozens of PRs per day. And now, design systems. So, personal favorite. Regarding designers and engineers, our reality was that in the beginning we had around 15 designers and mobile engineers. And now that we went into hypergrowth, we are around 80 designers and engineers. As you can imagine, if you don't have a structure that supports this, it's basically a recipe for failure, as you have 4 different teams: Android, iOS, design, and web, and infinite number of lines of communication. So one good example of all this misalignment between all these teams could be broken down to this definition of a simple item divider. Devs and designers would have a conversation that follows more or less these lines. So the blue dev would say, is this the right gray for the divider? And the green designer would say, yeah, it should be. Red dev would come in, I thought it was this one. And green designer actually says, no, it's this other one. So at the end of this conversation, we realized that not even the definition of a simple divider gray is actually easy to grasp. So the reality is that at this scale, teams of designers define their own informal contract, then another team of designers had a second informal contract, and the developers had their own definitions. So it was clear that we had to align all these contracts into one so that we could sit around it and have the same design language in order to get better understanding. This language, thankfully, exists, and it's called the N26 cross-platform design system. This cross-platform design system is actually embodied in the form of a system glossary. And in my unbiased opinion, it's amazing. So if you think about it, it works as live documentation for designers and developers. So we can release this internally. Designers get updates every day or every week. And they always just have to go to their phone and see, okay, this is what we have. And also works as a playground app for devs when they're doing like some UI elements that require a lot of tuning and a quick feedback loop. Moreover, the system glossary is built with the same design system that is trying to showcase. So we have this kind of self-loop thing, inception, I don't know really well how to describe it. The system is then organized into major ideas. So the first one is the fundamentals. They define the visual language of our system and what are the ground rules when it comes to things like typography, colors, spacing, or corner radius. For instance, if you tap on the color section, you will see all the colors that are allowed in the system, their name on the system that should reflect the use case in the color background screen or color background error, and their color resource name. Also, when you get to build a design system, there are things that come almost for free, like multiple teaming. And then this was basically the first thing that we have to build, fundamentals. And we built more like spacing and typography that defines what are the styles that we have and the use cases on which they should be used. And once this is done, you can start actually building things using them. So you have this kind of Lego block feeling. And you can, at the left, you can define buttons that would be using color fundamentals, spacing fundamentals, corner radius fundamentals. And then at the right, you can see our horizontal button container, which is basically a component that uses the button component and spacing fundamentals to define how actually buttons are displayed in our app. So once the design system is built, building your UI would be as easy as this. Let's take this example of the space detail screen. We will basically draw our UI for the list of the transactions inside this space. So first we would have to start by declaring the section header. Easy. Then subsection header. Easy again. And then transactions. I'm going to say easy. And basically, this is it. This is all I have to do, and I just wanted to give like kind of a small inspirational remark. Just give me 1 second. So basically, I want to show that, okay, we have a big team, we are a big company, but creativity and innovation doesn't have to stop. And I want to just give some minutes to discrete mode, which basically is a feature that allows you to blurry your balances by waving your hand on front of your screen. So more or less like this. Basically, this started as a initiative that we have in the company that is Get Stuff Done Days. That is basically you have a couple of days every 6 weeks where you can work, study, whatever you want. And basically in the company of more of 1,000 people, 2 persons were able to develop and drive the launch of this feature. So Raul came to me and said, man, I have this idea, let's do this. I actually did almost everything, and I was super excited with this. And I said, yeah, man, let's do this. And we basically built it on 2 days. The problem came after. We wanted to ship it, and nobody wanted to own it because product didn't define it, design didn't design it, QA didn't test it, so it's all about the developers. But still, it has a good ending. We basically had to grow our sphere of influence in the company. And we basically split ourselves and started talking to everyone. Eventually, we got the approval for everyone. And in the end, what is good here is that basically one of the most loved features for this year was started by 2 random guys on the Android team. And that's it. Thanks for listening, and feel free to do some questions. Yep.